Here at the upper left we have a shell ferromagnet, and at the lower right we have a free pole magnet. Now the shell ferromagnet consists of 2 nanometer ferromagnetic precipitates embedded in a strongly anisotropic antiferromagnetic matrix, which is usually tetragonal. In the case of a free pole magnet, we have a cubic ferromagnet which is embedded in another cubic antiferromagnetic. In this case, it could be, for example, iron 2 manganese gallium embedded in iron manganese. This has a weak antiferromagnetic anisotropy, the iron manganese, so that there is no shell, as in the case of the shell ferromagnet. In the shell ferromagnet, as we know, the antiferromagnetic anisotropy of nickel manganese is very strong, so that it pins the outer shells of the precipitates. Now let's take 2 of these precipitates representing each end of the sample and approach it with a magnetic field to the left. You see that the core spins are free to rotate, but the shell spins won't rotate, so that the sample is not attracted. But now in this case, if the magnetic field aligns the core spins in the same direction as of the shell spins, the sample will be attracted. So now let's approach the sample from the other end with another magnet with the field in the same direction. You can see that the sample here can be manipulated up and down. And now if we rotate the magnet, the core spins towards the left will point to the left, cancelling the magnetic field so that the sample cannot be manipulated. Now, let's look at the case of the free pole magnet. If we approach a free pole magnet from the left, you see that the whole sample can be magnetized with the spins in the field direction as shown here. If you rotate the magnet, then you magnetize the whole sample in the other direction as well. So, now, if we approach the sample from the other end with a magnet in the same direction, you can see that you can still manipulate the sample as you would in the case of a shell ferromagnet. But when we rotate the sample, you see here that unlike the shell ferromagnet, you can still manipulate the sample, although the field opposes the field of the magnet applied from the left. So that's why we call this a free pole magnet.